So in the first half, I worked through the problem sets 12 and 13 with the help of ChatGPT. In this second half, let me try a couple questions. We don't have a lot of time, but enough time to try a couple questions with uh, ChatGPT, asking it nuclear and particle physics questions. And the main thing I'm really interested in is just how well it answers those questions. Because I will tell you, even a year ago, when I taught this class last, this modern physics material, nuclear and particle physics, is that's where it was struggling before. So I'm really interested in seeing how well it answers. Let me save myself a little bit of work and wait, where's my previous thing? Mm. I want you to just copy and paste my previous instructions so that type everything from scratch. I'm just gonna copy this, just being lazy for a bit, and then hi, I'm working on my nuclear and particle physics. Still lower division homework. And you have some of the questions. Yeah, yeah. Okay. Um, so let's just ask a question from problem set 14, and then another question from 15. Find yet. These look, these are easy enough. You just construct the periodic table for the atomic number, mass number, subtract the atomic number from that, and hopefully, I think everyone can do that easily enough. So let me find something that's more meaningful. Mm. Do I want to do this integral? We've already done the integral in the first part, so let me not do the integral again. I wonder. So for reaction like this, I can imagine someone making a mistake. Let's see, you do californium 249 into alpha decay. So there's no neutrino. Let's say, I mean, you need to consult the periodic table, but let's say you get confused by this yellow thing, thinking, oh, I must have gotten enough of it right. What did I miss? Did I, miss this number? Should this be 244 instead of 245? And wait, is it getting closer? No, 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 it's getting farther away. I think it does it by amount of percentage of character match. Um, so it feels like I'm close on part A, but I can't quite get it right. I thought alpha decay didn't change any particles, just to rearrange that. And rearrange the nucleus with the two protons removed is no longer californium. I wonder if ChatGPT will tell me what element it becomes. It's the kind of thing that I don't have memorized. That's why I'm linking you to periodic table so that you can look it up too. So if you have californium, it should become curium. I'm assuming named after Madame Curie. Uh, is that two protons? Yeah. Yeah, drops by 4. Californium. Yeah. Oh, okay. I don't have access to a periodic table. Can you tell me what the element with the two atomic numbers shorter than californium is? I'm just curious. Does it is it able to answer that? Maybe. Uh Orion. Wow, yeah, yeah, that's great. Uh, yeah. Energy released in the decay. Oh, Oh, so here you can actually. This is a mistake that I got trapped a couple times. So let me make that mistake for you. So if you look up, let's say, mass of Californium 249, so you get, oops, what? Californium. You get that? So let me just uh, look up everything. Curium 245, and you have mass of alpha particle, and it gives you helium 4 atomic mass. Yeah, so I think it's gonna have that, or maybe it doesn't. For this question, I think it's gonna work out fine because it has to do with the electron mass, and I think the way electron mass is included here for californium, and then curium, and then alpha particle, they will just balance out. I think. Let's just double check. So let me do it in a calculator first. I'm gonna do 249.07485 minus the curium mass, 245.049 minus the alpha particle mass, 4.00260. That's in atomic mass unit, so I'll say 0.00666 U in MeV per C squared. So that should be right. Yeah. Okay. So let me ask ChatGPT this question. Um, for part B, I got the correct answer after multiple tries. I thought I had to account for the curium having fewer electrons than californium, but the only answer that was graded as correct was when I just ignored the electron mass. Should I file an errata? And it might double check the number for me and say that it's a correct number. Oh. Can it look up the numbers itself? Maybe. Um, is correct, huh? Yeah, yeah. Both sides have equal. No errata needed. Yeah. It's an atomic mass, and that already takes care automatically. Yeah, 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 yeah. Yeah, as long as for the alpha particle mass, you actually use the helium 4 mass, not the actual alpha particle mass, which is helium 4 mass minus 2 electrons. Uh, yeah, yeah, yeah. Tables most so usually it's atomic masses. So yeah, yeah, yeah. Final subtlety. Yeah, yeah, yeah. But yeah, that there's the atomic energies, but we can ignore that. Yeah. Ah, thank you. That's work for me. Okay. I probably should move on to problem set 15 and ask it at least one particle physics question before we run out of time. Uh, all right. Is there an interesting particle physics question? I think there's a question about conservation laws. So yeah. So let me try choosing everything that like let me try ignoring this note and see what happens. So this is, oh wait, this is forbidden. this lambda, not this is a baryon decaying into. I'm pretty sure. Well, let me. I'm. Oops. PDF. PDG. Oh. So I'm pretty sure. Lambda not doesn't have enough mass. So let's say being fastidiously correct, I say so lambda 0 should be, wait, I need a baryon table. Um, yeah, lambda baryons. So lambda 0, yeah, it has mass of 1115. Maybe it has enough mass for, uh, let's just check. Does it? Oh, I guess the easiest way to check is the decay mode. Oh, it does have. Okay, so that's not forbidden. It only decays into pions and protons. Never mind. And the positive pion. That's a lot. Um, Antimuon. So yeah, I should have selected because it's forbidden. There should be a muon antineutrino. And this one meson into, I think that should be fine. And pi meson into electron. Yeah, it's rare, but it does occur. And proton into, ah, so this is forbidden because of energy conservation. Now, if I select it, it'll say I only got it partially right. But I can imagine someone doing this. Like you are consulting particle data table, like I'm doing right now, and look under proton, and it should say proton is where's the proton? Is that it should say proton is a stable particle, doesn't decay into stuff. So you check it, it's forbidden. And muon, that's fine, yeah. Okay. So you perplexed. Say, uh, I'm not sure. So you ask, oh, I'm not sure why this is getting graded as incorrect. I'm not sure why this is getting graded as incorrect. I even checked the tables at pdg.lbl.gov to make sure that um, all the decays I checked are not allowed to occur. I wonder if ChatGPT can reason through the question instruction that even though, yeah, proton doesn't decay into neutron and positron, at least not free proton doesn't. If it's like within a nucleus, there could be a odd situation where you get that beta plus decay, but um, eh, I'll be impressed if ChatGPT figures out this is the choice that I should uncheck. Uh, let's see. After this is done, let me just check if there's another interesting question, but this might be the last one. We'll see. Mhm. I don't know what it means by revising the lepton number conservation. Are you changing the laws of physics? Oh. It's taking so long. Mhm. The number for each candidate. Okay. Good catch. Okay. Um, oh, I don't get it. I. Oh wait, did I check the wrong thing? Oh yeah, yeah, yeah. Pion. That does. Why did I check it? I even said it does decay that way. Okay. Yeah. Hmm. Okay. I realized I uh got mixed with pion decay. Yes, pi minus can decay into electron and electron antineutrino, but it's still saying I got it incorrectly. Um, I plus. Did I mess something up? Oh, I did mess something up. Yeah, yeah. Okay. Oops. And oh, yeah, I caught pi plus error after I sent the last message. I'm assuming it's gonna say something about the pi plus, but still not fully correct. One mismatch. I'm looking for it to explain the proton decay because that's the one where um, I can argue with it. Hey, I don't see it in the PDG table, and I wanted to explain this note. Yeah, lepton number conservation. Proton decay, yeah. So it's arguing lepton number is conserved. Uh, uh, I see what you are saying, but I don't see proton decay in the PDG table. So it doesn't happen, right? Just, being obstinate one last time. And then I'll, uncheck, submit, all correct, and say, all right, thank you. Yeah, because energetically impossible. Not that it violates the lepton number. Yeah. Yeah. Good. It's Really good. Thank you. So I think that might be time, unless there's a super interesting question that we haven't gotten to. Oh, yeah. Um, uh, I wonder. Yeah, I wish I had more time to work through some of these questions, but so let's do it this way. I think some of these might involve strangeness. Um, okay, I'll say, okay, I'm almost out of time. Okay, I'm almost out of time. I have another matter to attend to. Um, can you give me some quick hint with each of the parts here? Here, I'm especially struggling with identifying when strangeness is violated. I just want to see how well ChatGPT handles material that deals with basically particle physics beyond the ordinary particles. Strange quarks, charm quark, bottom quark, up quark, no, hop quark. Um, so as it's answering, can I do it? So here it violates the baryon number and charge maybe? No, not charge. Um, oh wait, minimal nudge for each line. Yeah, ordinary, strangeness 0, chaos. Oh yeah. So these numbers help because I don't have these memorized. I would have to look them up from the PDG table actually. Um, so hyperons all have strange. Yeah, yeah. Because I think the strange quark has a strangeness of -1, so all the baryons would have negative strange number. Um, and yeah, omega is a strange number of -2. No, -3. So Z must have strangeness of -2. Um, baryon number, yeah, charge. Yeah. Um, so compare baryon number. Yeah, compare baryon number. Um, initial S is 0. Look up, see if the total. So K minus is a strangeness of minus. Yeah, so this would violate strangeness. Um, strangeness does balance something else. Oh yeah, it's two baryons on the right hand side, so it's baryon number. Yeah, and yeah, there might be some other stuff that I need to check, like angular momentum probably. I think because K-on is it's I think a spin zero particle, and they are both a spin half or there. So yeah, uh, uh, good. Thank you. You have been very helpful. Yeah, so again, it's really a technology that even last year I wouldn't have recommended using it as a virtual tutor because it was frankly not all that reliable. But today, really the main caution I have for everyone is make sure you are using it correctly. It's uh, generative AI like this. It's like a very sharp knife. You can use it correctly, do great things with it, chop the onions finely. You can also hurt yourself. So when you have access to something this powerful, the burden is on you to use it in a way that actually helps your learning, not hurt it. So that's all. Thank you so much for joining these sessions, though, for the semester, and I have hope you have a great summer. Bye.